Hey guys, this is your first set of notes for Unit 3. This unit is all about thermochemistry and thermodynamics. You guys might have touched on this last year when we were at home during the lockdown stuff, so this could be completely new to you. So make sure you're paying attention and take notes as we go. All right, so first, what is thermochemistry? Thermochemistry is the study of heat released or the heat required by chemical reactions. So in this example, I have a combustion reaction. My products show that I also have energy being released. So in this case, it would be energy in the form of heat. So anytime it's released or if a reaction requires heat, that is thermochemistry. We're also going to talk about the first law of thermodynamics. This says that energy can be converted from one form of energy to another, but it can't be created or destroyed. So for energy, first you have to know what energy actually is. Energy is just the capacity to do work. Work is a process where there's a change in energy. There's going to be a lot of different types of energy. Some of the types of energy are radiant energy. This is when you think about like electromagnetic waves or the electromagnetic spectrum, or even just energy from the sun. All of that is radiant energy. Next, we have thermal energy, which we will focus on quite a bit. This is from the random motion of atoms and molecules. Then we have chemical energy. This is what's stored within the bonds of chemical compounds. We have potential energy, which you guys have probably heard a million times. This is just stored energy based on an object's position. And then kinetic, you should already know as well. It's produced by a moving object. For energy and our units of energy, heat, work, and energy are all measured in joules. We represent that with a capital J. 1 kilojoule is equal to 10 to the third joules, so you may need that later on. We also need to know about calories. We'll just say CAL. 1 calorie is the energy needed to raise the temperature of 1 gram of water by 1 Kelvin. So 1 calorie is equal to 4.184 joules. 1,000 calories is 1 kcal, or you can just have capital CAL. This is your food calories that you hear about all the time and you see on the back of your food labels. What is thermochemistry? So heat, you also need to know this definition. Today is really just mostly definitions and kind of introducing this topic. We'll get into some math stuff next class. So heat is a transfer of thermal energy between two substances at different temperatures. Heat can flow or be absorbed or be released. Thermal energy and heat are not the same thing. So thermal energy depends on the kinetic energy of the substance. Heat is the transfer of energy from one substance to another. And temperature is not like either one of those things. It's a measure of the average thermal energy of an object. You will also need to know the difference between exothermic and endothermic. Exothermic is any process that gives off heat. It's going to transfer thermal energy from the system to the surroundings. So that wording is important, the system to the surroundings. Exothermic reactions feel hot to the touch. They're releasing heat. Then we have endothermic processes. This is any process in which heat has to be supplied to the system from the surroundings. Endothermic feel cold to the touch. So here's a few examples of that. In that top picture, we have burning fossil fuels. That's going to be a release of heat and energy, so it's exothermic. The next picture, we have sodium and chlorine forming salt. That's endothermic. That's actually a very cold reaction. And then we have photosynthesis. That's actually endothermic because it's requiring that energy input from the sun. Okay, so ignore this slide. I forgot to delete it. But now you have a couple of questions over the notes to go ahead and fill out. And please make sure you finish